So welcome everybody to this latest A2 video on trigonometry, and where we'll be continuing with harmonic form with a focus on solving equations from harmonic form. Now, one of the advantages of expressing an equation involving both sine theta and cos theta when it cannot be converted into tan theta into harmonic form is that it is much simpler to then go on and solve. So for example, if we had 3 sine theta plus 4 cos theta equals 3 and I wanted to go on to solve this, obviously my initial things would be thinking, sine theta cos theta, well, sine theta over cos theta equals tan theta. However, if I take the cos theta over to the other side, I'll notice I end up with 3 sine theta equals 3 minus 4 cos theta. So then trying to get the sine theta over cos theta is not going to be a possibility. However, if you recognize that when you have got sine theta and cos theta, you can use harmonic form to kind of represent that, to turn two trig ratios into one. Now, once you've got it into this frame of mind, then it becomes a lot easier to solve, because I can solve this just like solving any algebraic equation involving layers and steps, to then just make theta the subject and then abiding by the sort of range of theta that the question is asking me for. So again, once we have only one trig ratio in the equation, we simply solve the equation for theta, given the values within the stated range, and there'll always be a range that is stated. Now, one thing that is worth noting is that as theta will be accompanied by an angle, so as you can see in our little bracket here, where you're adding or subtracting a particular another angle, then always to think about extending the range in which it's given. So for example, if they're asking for theta that's between, let me just get rid of that, between theta and 180, because you're going to be either adding or subtracting values at the end, you may want to think about extending this to, let's say, minus 90 and that to 270, let's say, just to play things safe. And obviously when you make theta subject, you only want to include angles that satisfy the original range that's stated. So let's have a look at this very first example. So in this question it says solve the equation of 4 sine x minus cos x equals 2 for 0. X is between 0 and 360. Now, initial thoughts may think, without thinking of harmonic form, because we've got no r cos or r sine anywhere in this question, maybe to initially think, well, okay, I've got single sine and a single cos, so let's think of tan, because that's the first trig identity that comes into mind. Now, the problem with that is the fact that if I then start working with this to try and get sine over cos, to convert those two trig ratios into one, then what I end up with is 2 plus cos x, and there's no way then of me taking this side cos x of dividing both sides by cos x. So for example, I could do sine x over cos x, but then I'd also then need to divide 2 by cos x as well. And again, there's no sort of easing of this to try and convert it. So what you need to try and do is spot that this is a harmonic form question. So the first thing we need to do before we go on to solving this equation is step 1 is convert into harmonic form. Now the question is, well, as there's no indication of harmonic form in terms of do I use r cos or r sine, well, it doesn't really matter. You can choose whichever you prefer. Now, I would always go for whatever trig ratio is given first, go for that one. So here what I'm going to do is I'm going to convert 4 sine x minus cos x using r sine, and it's going to be theta minus, because it's the same sign as that, alpha. So again, what I'm then going to do is then expand this. So I've just got 4 sine x minus cos x equals r, and then substituting this into the compound angle formula, I'm going to get r sine x. Well, actually, it shouldn't be theta, it should be x. Let me just get rid of that and change that to an x. So r sine x cos alpha minus r cos x sine alpha. And then what I then want to do is then compare the coefficients. So here I've got 4 is going to be equal to r cos alpha, so 4 equals r cos alpha, and 1 is going to equal sine r sine alpha. So using these, what I then get is that tan alpha is going to be 1 over 4, and then working out what alpha is using my calculator, either using arctan or inverse tan. I get an angle of 14.0 to 1 decimal place. Now from this I then need to work out what r is. So from this I get that r squared, let's use different colour, so r squared is going to equal the coefficient of sine x, which is 4 squared, plus the coefficient of cos x, which is 1 squared. Now you might think -1, but it's going to be plus anyway because we're squaring it. So r squared equals 17, so therefore r equals the square root of 17. So then converting that into harmonic form, what I then get is that 4 sine x minus cos x equals 2. Now this can be written as root 17 sine theta minus 14.0 equals 2. And this is what I'm now going to go on to solve. So again, just splitting the screen so you can see it all. So what I've got is I've got root 17 sine theta minus 14.0 degrees equals 2. And now I'm going to make theta minus 14 subject. So I'm going to take the 17 over to the other side. So I've got sine theta minus 14.0 equals 2 over root 17. I'm then going to take the inverse sine, so sine theta minus 14 is going to be equal to the inverse sine of 2 over root 17. So theta minus 14 is going to equal, now the first angle it's going to give me is 29.0 to 1 decimal place. And then using the graph or using cast, whichever floats your boat, I get my second angle as 151. Now obviously I need to work out what theta is, so what I now need to do is add 14 to each of those angles. So I get my final answers being theta equals, and it's going to be 43 degrees and 165 degrees. And just double check to make sure it is within the range, which it is, and we are good to go. So moving on to our second example, so it says solve the equation of 3 cos x plus 2 sin x equals 1 between the limits of 0, where x is between 0 and 2 pi, giving our answers correct to 2 decimal places. So for this, what we then need to do is the following. Now the first thing I should spot is that we are going to be working in radians. So we need to make sure that our calculator is in radian mode. So also notice that I'm going to be using harmonic form, hence the labeling of this video. So here what we want to do is we want to convert 3 cos x plus 2 sin x. Now again, it doesn't really tell me which of the harmonic forms to write it in. Am I using r sin or r cos? But simply because I'm starting with cos, it doesn't really make a difference. I could use either or. I'm just going to go for the cos version. So what I'm going to be doing is I'm going to be using r cos alpha theta, and because that's a plus, I'm going to be using minus alpha. So now finding r first, just to mix it up. So r squared is going to be the coefficient of cos squared plus the coefficient of sin x squared, which is 2 squared. So r squared equals, it's going to be 9 plus 4, which is 13. So r equals the square root of 13. Now in terms of working out what alpha is, so here I've got tan alpha equals the coefficient of sin x, which is 2, over the coefficient of cos x, which is 3. I'm then going to do the inverse tan or arctan of 2/3, and I get alpha in radians as being, I'm just going to type that into my calculator, of 0.588. And that continues. So from this, what we've got is we've got 3 cos x plus 2 sin x equals 1. Instead, I'm going to convert that into harmonic form, so that's the same as 13 cos theta minus 0.588 equals 1. And it's this that I'm now going to go on to solve. So taking this, I'm just going to write it out again. So I've got root 13 cos theta minus 0.588 equals 1. Well, first things first, let's take the root 13 over to the side. So I've got cos theta minus 0.588 equals 1 over root 13. And then I'm going to do the inverse. So theta minus 0.588 equals the inverse cos or arc cos of 1 over root 13. So if I just type that into my calculator, so inverse cos of 1 over root 13 equals, and I'm not to do math error, I get theta equal theta minus, say, 0.588 equals 1.2897, blah blah blah. Now, because we're doing it to 2 decimal places, I would always recommend just going that further. So I'm actually going to use 1.2897 as an exact values. Now, what I need to then do is find the other values. Now, if I look at my cos graph, because that's what I'm working with, and I'm going to be adding 58 degrees. So what I need to do is I need to find those values of where it equals 1.2. So from this, it's going to be, well, if that there is pi over 2, so let's just quickly from that, so that's going to give me a value of 1.57. So the values I'm looking for, these values between 2 pi, where 2 pi is here, is going to be that value there and this value here, and also that value there as well. So to find all my values, what I then need to do is add this on. Now, obviously, in terms of this negative value, if I add 0.588 to it, it's still going to be outside my range of 0 and 2 pi, because it's only this side of the graph that I'm interested in. So it's just those two values I then need to work with. So theta equals, and it's going to be 1.2897 plus 0.588 as one value, and then I need to do the second value, which is going to be 2 pi minus 1.2897 plus 0.588. Now if I then work those two values out, that's going to give me this, and it's a little bit complicated, but hopefully it still gives me the correct answer. So it's going to give me an answer of 1.85 as one answer, and then my second answer, which is going to be 2 pi minus, and it's going to be 1.57, 1.2897, and then I'm going to add 0.588 to that answer, and it gives me an answer of 5.58. And there are my two solutions.